All right, so next set of proofs, rhombus and square. So definition of a rhombus is a quadrilateral with 4 congruent sides. Okay? Or you could say it's a parallelogram with 4 congruent sides. So that's a little bit better because that gets the idea that opposite sides are parallel and all the rules that apply above. Now we're going to use the distance formula, but remember we also did that shortcut. So when we find the slope, if we just count on the graph, whatever number goes here, we can just plop in here, and whatever number goes here, we can just plop in there. So that's a little shortcut. So plot the points on the graph. -1, 3. So -1, 3 is right here. 3, 6 is right here. 8, 6 is right here. And 4, 3 is right here. So we connect, and we're trying to prove that it is a rhombus. Well, remember, when we have horizontal or vertical lines, we can just count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have the measurement of those points, and those sides. So again, this is A, this is B, that's C, and that's D. So we already know that BC, the measure, BC is 5. AD is 5. We just need to find AB and CD. So let's do that trick with the slope. Let's find the slope of AB. 1, 2, 3. So the slope of AB is up 3, right 1, 2, 3, 4. 3, 4. And DC should be the same thing. Hopefully. So from D we go up 1, 2, 3. So there's my 3. And right 1, 2, 3, 4. So they have the same slope. So we know it's a parallelogram. So now all we do on the distance formula, we make our life easy. AB, okay, watch how easy this is. Instead of doing y minus y, we just plop these numbers in. So y minus y is the number on the top, right? And this number here. It doesn't matter which one. We put 4, 3, or 3, 4. It makes no difference. So the distance is 9 plus 16, square root of 25. So it's 5. Whoa, wait a minute. Look at that. 5 all around. So it is a rhombus. Because it has 4, I'm not going to spell out congruent, 4 congruent sides. Now, is it a square? Well, it certainly doesn't look like a square. Okay? But, beyond that, if we look at the slopes, the opposite reciprocal slopes would be -4/3. And we can look, horizontal lines have a slope of 0. They are not opposite reciprocal. So it is a rhombus. That's it. Most specific name we can give it. Now, a square, we could just say it is a rhombus with 4 90-degree angles. Okay? Because we already know what a rhombus is. Now, can we say a parallelogram? If we said parallelogram, that's fine, but then we have to be more specific. If we say parallelogram, then we have to say with 4 90-degree angles and congruent sides. By saying rhombus, we already have that congruent side part of the definition. It's up to you how much you want to write. I will be open with what you do here. So to prove quadrilateral is a square, you must show 2 things. All 4 sides are congruent, so that's going to be the distance formula. Or just counting if they're horizontal or vertical lines. And 2 consecutive sides are perpendicular. Well, that means we need to do slope, opposite, and reciprocal slopes. So here we go. So point A is at -1, 0. Point B is at 3, 3. Point C is at 6, -1. And then point D is at 2, -4. Okay, I'm trying to draw the best, straightest lines possible and make our shape. Now, remember, we don't actually have to do the full long distance formula. We can kind of cheat. So we're going to count slopes. That's going to take care of 2 problems for us. So AB, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3 for BC, 1, 2, 3, 4. Okay, so this has a slope of 3 over 4, and this has a slope of 3 over 4. All right, now, for BC, I'm going to go down and right, so that's going to be negative and positive. 1, 2, 3, 4, 1, 2, 3. So that's down 4, right 3. Now let's do AD. 1, 2, 3, 4, 1, 2, 3. So that's -4 over 3. So when I do the distance formula, okay, I'm just going to do, since they're the same slope, I just need to do one of each opposite sides. So I'm going to do AB, and then again, I don't care which number goes first. Go plus, I don't know, fix that. Square plus this square. So I put 3 and 4. And it doesn't matter if I put 4 and 3. It makes no difference. And we just did this. So 3 squared is 9, plus 16, that's the square root of 25. So that's 5. Okay? So we know that AB is 5. Now we need to do BC. Now here, let's talk about this. This is where people make a mistake all the time. If you're going to put it in the calculator, here's the problem. -4 and 3. Here's what people do. Watch very carefully, because this happens all the time. Algebra 2, Algebra 1, whatever. You'll do this. -4 squared. Oh, whoops. -4 squared. And they say it's -16. That is incorrect. If you type it in the calculator like that, it is saying square the 4, then take the opposite. If you're going to put in the calculator, you have to do this. Or just always put a positive number in. When you square a number, it's always going to end up being positive. So when you write this, you don't have to put the negative with it. You can just do the absolute value. You can just do 4. Okay? Either way, you're going to get 16 plus 9, 25, and 5. Now, since you did 2 of the sides and the opposite sides are parallel, you know all the sides are 5. So you know this is at least a rhombus. Now we got to compare the slopes. We have -4 over 3 and positive 3 over 4. Are they opposite? Yep. One's positive, one's negative. Are they reciprocals? Yes, they are. 3 over 4, 4 over 3. So we have just proven it is a square because 4 congruent sides and 4 90-degree angles. And that's it.